An article stating that in a 1-year period, approximately 7.3% of adults in a country suffer from depression or a depressive illness. Suppose that in a survey of 100 people in a certain town, 5 of them suffered from depression. Conduct a hypothesis test to determine if the true proportion of people in that town suffer from depression or a depressive illness lower than the percent of the general adult population. So basically what we're saying is we're going to sample 100 people,
Right.
and we find out that only 5, but everybody's saying that 7.3% is what the norm is. So we want to know if this town is less depressive than the nation as a whole. Because only 5 out of 100, so only 5% of the people in this town were depressed, right? Which is less than 7.3. So whenever we're doing this, I always run through the first thing. Is this a test of a mean or a proportion?
Oh yeah, that's right.
A proportion, because I'm talking about percentages.
Right.
And I always sort of have to run through this. So now, what is my null and alternative hypothesis?
It was the P equals 106 and
So normally I'm going to sit there and say, what? Here's where I come back and I say, sometimes, and they don't say to do this in the textbook, but I always say, always write the question that you're sort of trying to answer.
the mean,
So
what
is town A less depressed than the nation?
is town
Because that's what it's saying. Conduct a hypothesis test to determine if the true proportion of the people in the town suffering from depression is lower than the percent in the general adult population. See where I highlighted that? So that's what they're talking about. So the question I'm trying to answer is, are the people in this town less depressed than everybody else? Is this a happier town? And this is where, when you start talking about directional testing, I can either say, is this a less depressed town or more happy? So I can make the direction go either way I want by just sort of looking at it. So I normally go with the alternative hypothesis first. So my alternative hypothesis would be that it's less than the nation as a whole.
Right.
Which means that my null hypothesis has got to have an equal sign. See, I can throw this one out because my null is not equal. I can throw this one out because they got the equal sign in the wrong spot. So see, the second one here and the third and the fourth one here, I throw out just because the null hypothesis has always got to have a equal sign.
Yeah.
So I want to know, is my town less happy? You see how I'm just walking through this? And I do this every time that I'm sort of working with these. So the next question, part C, says what? Is this a right tail test or a left tail test? So this is where I always go and I draw my chart. If I'm less depressive, that means I'm over here and I'm in this tail. I always hate right tail, left tail, so right tail. I normally try to avoid whether or not it's right tailed or left tailed, but I normally just look at it, is it one tailed or two tailed?
Was it right-tailed for everyone?
Huh? Was it right?
No.
If this one, are you saying,
Mine was left-tailed.
was your question more depressed or less depressed? I'm,
Lower.
yeah, so I,
but my numbers were
It's in a-
approximately 12.9, and then 9 of them suffered.
But it's still going to be a lower.
It said it was left tail. Got it right.
I always hate, that's where I always sort of, I draw the picture, huh? Well, I guess if I'm
Lower.
looking at it, that,
Look
Yeah.
at, this is our left.
if
Oh,
I'm
yeah.
looking at it, this is my left.
Yeah, yeah, yeah. That's what we were doing, looking at it forward.
Oh,
What, how many times have I told you in here, I'm terrible at direction?
Yeah.
I just want to make sure
Oh, yeah, this is here.
when looking.
I looked at it, I spun around and I sat there and said, I drew it.
You know, you're right, you said right, but then you wrote it on the left side.
Yeah, see, I'm terrible at left, right. I'm just
Mhm.
bad at it, that's, so,
I
to
just,
me,
I was
I'm
just a
never
little
going,
confused.
is draw the picture and make sure you got it in the
Yeah.
right place.
Yeah.
Because I'm always gonna look at that, I'm not gonna ask you whether it's left tailed or right tailed.
Yeah.
I'm gonna look at how you wrote it, I'm gonna look at your hypothesis and how you drew your picture. So always draw the picture. Because if you have it drawn like this, I know you've got it in the correct tail. And like I said, I'm terrible at left, right. Because here's what I did, is I'm looking at the screen here. When I turned around, I'm thinking that the picture's behind me and I looked at my right on this screen. Where if I'm looking here, I'm on that screen. See, left and right depends on which way you're looking.
Right, exactly.
And I was looking at
The only
this
reason I
screen.
asked is because I'm so not confident in what I'm doing.
Yeah.
I just wanted to make sure I knew what I was doing.
Yeah. Okay. So this is a left tail
tail,
test.
yeah.
Okay. What symbol represents the random variable for this test?
P not.
And since this is a proportion, we're using D, not. Okay, in words, define what the random variable takes. The proportion of people in town, the number of people in town surveyed not suffering, the number of people in the survey, the number of people in town suffering from depression or depressive illness.
Proportion of people in the town surveyed
The
suffering
proportion,
from
yes.
depression or
We are
depressive
doing
illness.
proportion, so I'm not, this is where I looked and I read low and clicked high. But it's a proportion that I'm doing.
Right.
Okay, so now I've got to sort of enter my X, so I calculate as a whole number.
You gotta look at the top part to see what your
Yeah.
thing says.
So my N, well, my N was
100.
100. The
Depending-
number of people suffering from depression in my question was
Was it 5?
5.
So 5 divided by 100.
So
Is your
this
P?
is 5.
5.
I know this gets a little bit screwy the way that we use a lot of variables, and a lot of times I define the variables, and in this particular case, I get confused when I start to think about what the X is. So you know how I always write N, and then I write how many? Because this is what I want to know, how many are suffering from depression?
Out of 100.
Out of 100. So 5 divided by 100 is 0.05.
Yeah.
Now, when I calculate the proportion, what you have to remember is when I'm working with proportions, this, does anybody remember the formula for this?
Is it the P times Q?
P times Q
Over
over
N.
N.
And I did that.
And this is where we gotta be careful, because this is P times Q, not P prime times Q prime.
Oh, what?
So I have to go back to the 0.073,
What?
because I use the P from the null hypothesis.
What?
The first question? On the second question?
I use this P. This is the P that I'm using.
Oh my goodness.
See, this is P, not P prime.
Oh my, see,
And
that's,
see, that's where it makes a little bit of difference, and that's where it gets real hard on this one, where you gotta be pay so close attention to symbols, because P prime is the estimated, but we're looking at P.
and then the Q is gonna be 1 minus that?
Then the Q is gonna be 1 minus that.
Oh my goodness.
So that's where you gotta be careful, so that's probably where you were making the mistake.
Big time.
So 1 minus 0.073 is 927. So I get this times 0.927 over n, which was 100. And I still want the square root of that. So 0.927 times 0.073 divided by 100 gives me and then I take the square root of that number.
This times this.
That's what
divided.
And I get 0.026 01356 da 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 da.
030 or 03.
Order of operations, I gotta do the multiplication first. Yes,
Where did those numbers come from?
what does this number represent? What does, huh? Do you see a prime sign on that?
Oh, no.
So it's not P prime.
So that
I
is
got it.
minus 129, 0.129.
Oh my
Mine
goodness.
Well, you gotta go back to the P of your hypotenuse.
eight. Yeah.
Oh
So
So-
is it 12.9% or the, okay, so it's 0.129 is mine.
Correct.
What is the Q?
1 minus that.
Oh,
That's a bit like mine.
okay, so mine
So
is,
it's just the leftover from,
mine is, okay.
yeah.
Let's see if I can figure this.
So if you're to make 100 or 1.00 would be minus whatever the prime is, just the opposite. So if it was like 0.10, the Q would be 0.9.
So P times
Whatever's
Q
left over. 1
divided
minus
by
whatever that number is.
n.
Okay, let me try.
That's,
So if I'm going to, if I do this with a calculation, see, in my problem here, this was 0.73.
what do you call that P with the P naught? You call it like the P proportion or P sample?
That's, I normally call it P prime for that symbol.
That's P prime? And
Like
the other
the
one
little
is just,
prime.
and the other one is, the one that we're using right now
It's
is
P.
just P.
It's the proportion of the population. The P prime is the proportion of the sample.
Okay, so the way I do this is I do the P times Q divided by N, and then I do the square root of that number.
Okay,
Is that how I do it?
so here's how I'm going to do it.
Okay.
There's my P. My Q is just 1 minus this value. Okay, then when I get PQ divided by N, okay, so that means I'm going to take and go P times Q divided by N. Now, if I'm looking at this, I normally have a box up here for N. I'm going to click on that box even though I don't have anything there right now. And I'm going to come back up here and enter my 100. And then I'm going to move this down. And then I'm going to take the square root of that.
Got it.
So equals square root of P times Q divided by N. So you said your Q, you said your P was what?
0.129.
129, which means your Q, okay, whoops. 0.129. So you should have got 0.0335. Huh?
Number is 100, and that's what's,
Yeah.
that is that.
What was your Q?
My Q,
Yeah, or your P?
0.089.
0.089?
Yeah.
So you should have gotten a 0.28474. Okay? Amani, what was your P?
I have no idea.
Look at your problem.
Part B.
Well, the P should be in the narrative.
117.
12.117?
0.117.
0.117. So so your standard, your error should be 0.0321. So I just calculated it for several different ones. But see, this is where doing things on Excel kind of helps, because P is the number, and I always get P from the hypotenuse. It's always the P that's tied to the hypotenuse.
Is that, so that's that, and then I have to do the square root?
Yeah.
So is this, okay.
So there's your P, your Q. Okay. Now, let Excel do this for you. 1 minus P.
Did I do that right?
Okay, and then this is, okay, and these are not P primes and
I know, I just put it in this
Oh, yeah.
with my 100,
Yeah. So it should be B 77 times divided by B 69. Okay, so that's good. So now you just need to take the square root of that.
Okay.
Order of operations, there's several things that you gotta walk down through. So I gotta go back. And I know this it's tricky, if you punched in the point, if you use the P prime, the proportion, you're gonna get something slightly different, and that's where the practice comes in. So if you were using P prime instead of P, instead of the P, it's forgivable on the homework, but that's why you gotta practice doing this. So I said mine was what, 0.073? So I'll get back to the right one. So I get 0.26, and then they want it rounded to 3 decimal places, so 0.026. And then there's the formula. P time, and see, it doesn't have P prime times Q prime. Kind of gave you a hint because there's no P prime, Q primes in any of these. So now I want to state the distribution. So what distribution are we using? With the proportion, we almost always use a normal. We're using the binomial, a normal distribution to approximate the binomial distribution. And then we have to count. Now, here's one where this kind of gets a little bit tricky. Because what I have to do to get the p-value is I first need to get my calculated test statistic. And they don't have you do that. How do I get my calculated test statistic?
What in the world? For which part?
for this problem.
Why do you have to get a calculated test statistic?
You always need a calculated test statistic.
Oh, for the Z, you mean, to get the?
Yeah, well, in this particular case, it is a Z. So
Yeah.
what is it?
Did I do that?
It's the X minus the mu.
Close.
It-
Because we're not working with means, so we don't have X bar and we don't have mu,
Oh,
right? We don't, it's not means testing, so we don't have an X bar and we don't have a mu.
The P prime and the Q prime.
No, that's how you calculate what goes in the denominator.
Is that with the alpha?
This is where you take the P prime, the one that you calculated from the sample, and you subtract the P. And you divide it by
Really?
this guy. I mean, it's the same, I keep trying to think, if you do the other one, remember we were doing X bar minus mu divided by a standard error, right? You're always going to be taking something from the sample and subtracting a population parameter. So a sample statistic minus a parameter divided by the standard error. Every time. If it's mean, it's going to look like this. Whether you're using a Z table or a T table. If it's a proportion, well, what does this represent? The mean is a sample. So if it's a proportion, I'm going to take the proportion of the sample, which is 3 prime. And I'm going to subtract the proportion of the population divided by this. Now, how we get this varies from case to case. Whether we're dealing with means, whether we're dealing with proportions. So see, if I'm dealing with proportions, we just did this. Right, up here, we said that this was equal to the standard deviation of the population divided by the square root of n. And if we were using the T table and we didn't know this, we used this, right? So basically, the pattern is the same. We just have to remember, am I doing proportions or am I doing samples or means? Well, if I'm using means, I have my sample mean minus my population mean divided by standard error. If I'm doing proportion, I've got my sample proportion minus my population proportion divided by some sort of standard error. Every time it's the same process.
Can you go back to the first one, sorry?
So in my case, it would be 0.05 minus 0.073 divided by,
Is that is that the standard deviation with the bar? Is that a bar over the X on that second one for the P prime minus the P?
Here-
Is that a bar or is that just from the sigma? Or the standard deviation sign thing?
they normally do not, because we're not talking about means, they normally don't, it's not a bar over it, because we're not talking
So
about.
just a regular
Yeah.
standard deviation? And,
Well,
oh,
it's-
okay.
it's the standard deviation that we're using to approximate the normal table for the proportion,
Oh.
which is the P times Q divided by, the square root of P times Q times divided by N.
Okay.
See, this is where I keep saying, we have to know what we're working with because we vary the way we calculate these slightly.
I know.
but the same process we're going to deal with. We're still working with a sample minus a population divided by some form of standard error. So if I go back to my Excel, and I'm going to get my test statistic. In this particular case, it's going to be 0.073 minus, no, it's, I got them in the wrong order. My test one was 0.05 minus 0.073 divided by this number right here that we just calculated in the problem, in the step above that. So I'm just going to click on that box. Now actually when I do this, I'm probably going to click on the boxes. So I didn't calculate my P prime yet. Oops. So it calculate, so here, so here's my P prime, which is equal to my how many divided by, whoops, divided by n. And my how many was 5. And then my Q prime is just 1 minus this. This is my standard error. We said that this was a left tail. What was my alpha? What's the alpha? Did they
5?
give us an
I
alpha?
think it's a 0.5, 0.05?
Well, if they didn't give us an alpha, what do we use?
0.05.
And put on the line.
So, and of course, if we click on it, the next step says our alpha is 0.05. So, when I get my test statistic equals my sample proportion minus the proportion in my null hypothesis. Every time, sample minus population divided by whatever form our standard error takes. So I get negative 0.884. That's my test statistic. To get my p-value, I go to my z-table. And I look at 0.88. So here's negative 0.88 is right here. So the p-value, that's what, the p-value is your probability. The probability is always in the meat of your table. So my p-value is 0.1894. So my p-value is 0.1894.
What?
Now here's where I tried to get you to think about it there's two ways I can look at this to decide, do I reject my null hypothesis or not? Do I reject that they are equal? And there are two different ways I can make that decision. I can either compare my test statistic to a table value based on my alpha, or I can compare my p-value to my alpha. I can do either one.
Okay, how'd you get 0.1894? Can I see your, what was your data that you used to get that 0.19894?
I calculated my test statistic.
Right, I got the p prime minus p divided by the standard deviation.
And then I went to the z table and looked that up.
Okay, I did that for mine, and mine is coming out wrong.
Yeah.
How wrong?
Really, well, okay, so I did,
If you're within 100th, it's probably not bad.
okay, so like I minus this, the 0.07 minus that, divided by this.
But see, by not putting parentheses in there, you make a big difference.
Oh my goodness.
If your numerator is one thing, it's got to be in parentheses.
One.
Are you using my numbers or your numbers? Okay.
Your numbers, check it out.
71210.
Okay.
Oh, no, these ones.
Yeah, this is good.
So just plug mine into, and then.
I mean, everybody's gonna get a different test statistic, and you're gonna have to go look up your p-value. Now, it is possible that your p-value is a little bit off, because I can look at this. My p-value I went and looked up at the table was 0.1894. That's what I found using the table. I can use technology.